Final review problem number 3. A digital audio compact disc, remember those? Carries data along a continuous spiral track from the inner circumference of the disc to the outside edge. Each bit occupies 0.6 micrometers of the track. A CD player turns the disc to carry the track counterclockwise above a lens at a constant speed of some number. So the problem is telling you that the way a CD player works is it adjusts the angular speed of the CD so that the linear speed or the tangential speed is constant no matter what radius you're at. So there's a laser that scans the disc for information, and that information needs to pass by the laser at the same speed, same linear speed, no matter what. So we're given V, the linear speed, and the CD player is going to adjust the angular speed. So find the required angular speed at the beginning of the recording, where the spiral of information on the CD has a radius of whatever. So we have this relationship between angular speed and linear speed. Omega is V over R. And so at the beginning, we'll just put in that initial value for the radius they tell you in part A. And same thing in part B, the outer edge of the disc, that same speed is constant, and we use the radius of the outer edge of the disc. So what's the average angular acceleration that the CD experiences? Well, angular acceleration is defined as the change in angular speed divided by time. We've just calculated both of those omegas in parts A and B, and you divide by time on the bottom. Just remember to put time in seconds. Assuming that the angular acceleration is constant, find the total angular displacement of the disc as it plays. So this is a good kinematics problem. So I'll write down our trusty problem-solving process. We know omega initial, we know omega final, we know alpha, we know t, and we want to find the angular displacement, delta theta. And so you consult your list of kinematic equations. There's several of them that you could use. I think I'll pick kinematic equation number 2. So that'll do the job pretty easily. And lastly, part E, find the total length of all that information on the CD. It sounds like it might be a hard question, but it turns out it's pretty easy. Because the speed, the linear tangential speed is constant, that means the distance is speed times time. So just multiply the speed by the total time of the CD. And it turns out that that's a few kilometers. So if you could unroll all the ones and zeros on that CD player, they would be a few kilometers in length. So problem 3 is a rotational kinematics problem, and it's making sure that you can use the kinematic equations, that you can use relationships between translational and rotational quantities, and it's also making sure you know kind of the names of things. I've noticed that something that trips people up sometimes is just realizing that there's a difference between angular velocity and velocity, or angular acceleration and acceleration. So keep in mind that if the problem asks for angular velocity, they mean omega, they don't mean v. That's just regular velocity.